everyone, this is our lesson on naming ionic formula or naming and formulas for ionic compounds. As you can see, I've got a guest star today who has decided he wants to come and be in our videos. By the end of this lesson, you should be able to interpret the name and formulas for compounds using the IUPAC convention, which is just the normal convention that we will use to name compounds. Before you get started, though, you may want to pause this video and go back and review ionic bonding and ion charges. So first, let's talk about how to get the formula from a name. So an ionic compound may contain a metal and a nonmetal, which would just be binary because it contains two different ions, or an ion and a polyatomic ion, which would be ternary because that means there are three or more elements present. When you are writing the formula from the name, you write the symbol for the cation and the anion, including the charge. So if it was sodium, you would write Na+. If it was chloride or chlorine, you would write Cl-. If the charges are equal but opposite, they will cancel. So +1, -1, +2, -2. They just cancel out. But if they do not cancel, you use what's called the crisscross method to get the subscripts on each element. So the exponent of the cation becomes the subscript on the anion. So let's kind of show you what that looks like here. If we are trying to figure out the formula for lithium oxide, we've got Li+1 for lithium, O2- for oxide. These charges are not equal but opposite, so you would circle just the number, not the symbol for the charge, and then you would crisscross them to become the subscript on the opposite element. And this is a reference here, if you look at it, to a song from the 90s by a little band called Crisscross. You can ask me about that in class if you want to know more. All right, so now let's go ahead and try a quick example. So we're going to write the formula for lithium phosphide. And it says to change this in your notes, so I probably have the wrong one typed down. So first, you would write the symbols and the charges. So again, lithium is +1. Phosphorus or phosphide is -3. Are the charges equal but opposite? No. So we would use the crisscross method to figure out our final formula. And when you do that, it becomes Li3P. You use the crisscross method to balance the charges because an ionic compound should always have a net charge of 0. All right, so you go ahead and try the next example. Pause the video and try to write the formula for magnesium fluoride. Now let's talk about names from the formula. So if I give you the formula, how do you name it? First, you have to make sure the compound is ionic, so a metal and a nonmetal. Then you will name the metal first, and there's no change in that name. So if it's Na, the name is sodium. Then you will follow it by the nonmetal name, but you do change the ending on the nonmetal to IDE. So chlorine becomes chloride. So if we've got NaF, Na is our metal, doesn't get a change, so it's sodium. Fluorine becomes fluoride, and as you can see through with these examples. Keep in mind, the crisscross method and the charges here do not affect the name of the compound. Okay, that is very important, a huge difference between ionic and covalent compounds. So now let's go ahead and name this first example. This should be a pretty basic one. We name the cation, then the anion with the IDE ending. So we've got sodium, and then chlorine becomes chloride. You do not... You butthole.
What did it cut off?
Yes. Sorry, my son kicked me off the screen. So sodium chloride, chlorine becomes chloride there. And then... I lost my train of thought. Spelling here is important because I will count you off if things are not spelled correctly, but I will not count you off if you try to capitalize things. So capitalize or not capitalize is fine. And go ahead and try to name. Let me go back. Go ahead, pause the video, and try to name your example down here, Ki. All right, now let's talk about using transition metals. So for transition metals, we know that a basic metal, a 1A, 2A, or 3A metal, the charge does not change the name of the compound. But with a transition metal, we do have that change. Come on. There it goes. If the metal is a transition metal, see, I shouldn't abbreviate that TM or it's going to do that. You will use step 2 on the previous slide, so it's still name of the cation, name of the anion with IDE ending, but where it does change is now with the metal, you will add a Roman numeral to tell me the charge. Otherwise, we're not going to know which Roman or which charge we're using. If I have copper and oxygen together and I just write copper oxide, that's not enough detail because it could be copper 1 or copper 2. The transition metals can have multiple charges, so we have to be specific in the name. You look at the anion charge to determine the cation charge to cancel or balance. So here's a good chart. If you want to, I would suggest maybe copying this down if you have a chance in your notes, just so you have it for reference. I will also show you on the periodic table how to locate these. So let's try this example. So we need to name Fe2O3. You start by naming the cation and then the anion with the IDE ending. So our cation is iron. Our anion is oxygen, which becomes oxide. So we've got iron oxide. Yes, we do. You determine the total negative charge. So oxygen, we know, has a -2 charge. Ouch. But there are 3 of them. So my total negative charge is -6, which means my total positive charge has to be +6. Okay, remember, ionic compounds won't have a net charge of 0. Well, since it's +6, we have to split that charge onto each cation. Since I have 2 of them, we're going to take that +6 and divide it by 2, and that's going to give us a +3 charge on each. And we would know iron takes a charge of either +2 or +3. Those are the only options it has. So the name here is going to be iron 3 oxide. All right, guys, so you go ahead, pause the video, and try to name SNS2. All right, and let's finish up by using polyatomics. If a compound contains a polyatomic, these are on your reference packet. Name the cation the same, just as usual, followed by the polyatomic, and we do not change the name of the polyatomic. It is specific to that formula, so we do keep it the same. So that makes these pretty easy. A hint to know if a polyatomic is being used is to look for more than 2 capital letters in your compound. If you see more than 2, you have a polyatomic present. When writing the formula with a polyatomic, be sure to balance the charge. If you have to add a subscript to a polyatomic, so if you need more than 1 of your polyatomic, you have got to put the formula of the polyatomic in parentheses because that subscript has to apply to everything in the polyatomic. So here's just a quick rule for your naming ionic compounds. And as you can see down here, we have this arsenate. It's in parentheses because that 4 needs to go on every part of that arsenate polyatomic. All right, so go ahead. We're going to go ahead and try to name this one together. So this is NH42SO4. Oh, and sodium carbonate, sorry. So we're going to do sodium carbonate first. We write the symbols and the charges. So we've got Na +1 and CO3 -2, which we got from the reference packet. They are not equal but opposite, so we're going to crisscross those charges. And our formula comes out to Na2CO3. And remember that 3 was already on the polyatomic, so we do not need parentheses for that. Then we need to write the name for NH42SO4. Name the cation and anion. Both are on your polyatomics chart. And there's no name change. So NH4 is ammonium. SO4 is sulfate. So your answer would be ammonium sulfate. So now you need to go ahead and try these two examples. All right, so now you should be able to name and write the formulas for ionic compounds.